In this lesson, we're going to give a brief overview on how to solve a system of equations by graphing. To graph a line, typically we like to see it in slope-intercept form. So let's review what slope-intercept form is. It is where we have an equation in the form of y equals mx plus b, where when we put a box around the number in front of the x represents the slope, which can be referred to as the rise over the run, okay, or it can be referred to as the change in y over the change in x. But regardless, the number in front of the x is always the slope, and the number, including the sign, that's at the end, so after the x, is called the y-intercept, which is where we get the term slope-intercept form. First word, slope, first letter, slope. Intercept, the last letter is the intercept. Where on an x and y axis, here's our x, here's our y, the y-intercept happens somewhere along the y-axis, somewhere along here. You're going to plot that point. If it's positive, it's above the x-axis, somewhere up here. If it's negative, it's going to be somewhere down below the x-axis. Let's get to an example here. It says solve the system by graphing. So we need to graph each line on the same graph. So this line, I need to pick out two things to help me graph. I need the slope and I need the y-intercept. The slope is the number in front of the x. That's just a negative sign. Well, we never write -1 in front, so the slope here is -1 over 1. The y-intercept is the number after the x, which is 4. To graph, the y-intercept is what starts it off. First point I'm going to plot is the y-intercept here at 4. So I go along the y-axis and I go count up 1, 2, 3, 4. I plot my first point. Now I use my slope. Remember, it's the change in y over the change in x. So I start at the y-intercept, and it's -1, so I'm going to go down 1, and it's over on the x-axis a +1, so I'm going to go to the right 1. I'm going to repeat that, down 1, over 1, down 1, over 1. Okay, it's a downward slope, so my dots have to be going in a downhill action. If I wanted to go the other direction, I would have to go up 1 and to the left 1. So up 1, left 1, up 1, left 1. We always want one direction going positive and one direction going negative. Now I connect those dots as best I can. It's kind of hard on the iPad, so bear with me. Well, let's graph the second line. I'm going to choose red. So again, two things you got to pick out. You got to pick out the slope and the y-intercept. So the slope is the number in front of the x. Here it's 1/2. The number after the x is the y-intercept. It's -2. So I'm going to go below the x-axis because my y-intercept is negative. I'm going to go down 1, 2. There is where the y-intercept is -2. And now my slope, again, is change in y over the change in x. So that means I'm going to go positive direction 1 and to the right 2. Up 1, over 2, up 1 and over 2. And I repeat. I want to go the opposite direction from the y-intercept. I can go down 1 and to the left 2 to kind of put a mirror image of these points. Now I can connect them Now, in a system of equations, our solution happens to be where they cross. And so the solution to this system of equation is the point that they have in common. And that point is the x value is 4 and the y value is 0. There's my solution. If we take a peek at one more here that's already been completed, again, we would pick out the y-intercept and the slope. So our green line starts at -2 and goes up 1 and over 3, up 1 and over 3. The reason we do the mirror image is because if we started and just did up 1 and over 3 and just went this way, we would never have found the solution here. Okay, you always want to make as many points as you can on the graph in order to find the solution. This is a tricky solution because it's all the way over here on the left. So if you're in doubt at where it's going to cross, always make the entire graph. Okay, always plot all of the points that you can find your solution. Solution happens where the points cross. Now keep in mind that sometimes if we have a set of equations where the lines happen to be parallel, where they're never going to cross, meaning that their slopes are exactly the same. When they don't cross, remember that is when there is no solution. Okay, one last example here, ignore that for a second. If we need to check to see if that ordered pair is a solution, so we have 3, 2, we need to check to see if it's a solution. I'm going to plug these values in, this x value and this y value, into the equations. So the top one is 2 times x, so I'm going to do 2 times 3, plugging the x value in for the x, plus 3 times 2 for the y. So I get 6 plus 6, which is 12. That works out. Now I'm going to check the second equation here. I'm going to plug the 3 in for this x and the 2 in for that y. So we have 8 times 3 minus 6 times 2. And we get 24 minus 12, which is 12. And notice how the 12 and the 24 do not match. So therefore, this ordered pair would not be a solution. If we plug it in and we get something that works, it is a solution. So I'm going to show you a quick example that's already been done. So if I plug in 2 for x and 4 for y, we get -6 for the top equation. And if I plugged in the 2 for the x and the 2 for y in the bottom equation, we get 8 as our answer. That works out. Therefore, it would be a solution.